So, Skibidi, it is Lewis. Today you're going to learn Newton's laws of motion in a Gen Z style. First law: a body at rest is at rest until a force is applied that will make it go from rest to motion. I bet this is how Newton felt when he discovered that a body will be at rest if it has rest. Alright, let's get to a car. Car is moving at a speed of 100 kilometers per hour. You have to stop the car and bring it to rest. How will you do it? You will apply brakes. The brakes will be in the opposite direction of motion, which will result the car in going from motion to rest. Newton's second law deals with force and how things like mass and acceleration affect the strength of that force. As mass increases, the force also increases. Why? We know that weight equals to mg, and weight is a type of force. So we can write this as F equals to mg. And as mass is higher, the force that will be calculated will also be higher. Acceleration is how fast you can go in that specific amount of time. Acceleration depends on three things: the final velocity, the initial velocity, and time. When you travel with a higher velocity, the force you exert also increases. When we multiply mass and acceleration, we get what is called force. So force is the product of mass and acceleration. Now we study Newton's third law of motion. But what is it? Newton's third law of motion states that every action force has a reaction force that is of the same nature and same quantity and is in the opposite direction of the action force, which is the direction of motion. Imagine you are trying to hit or punch the wall. So the force you are punching the wall with, which is with your hand, so the direction of motion is your hand punching the wall with a force maybe of 5 newtons. So when you hit or punch the wall, at the same moment, at the same time, you experience a force of 5 newtons back from the wall, which means the wall also hits the hand or the fist. So the action force here is your hand hitting the wall, and the reaction force is the wall hitting the hand. Then there's another example, which is of a gun recoil. Now what happens here? So when you fire, the gunpowder gases in the gun exerts a force on the bullet, which makes the bullet move through the gun and go out. While it goes out, the bullet also exerts a force on the gun, which makes a gun go backwards. Now we come to Newton's fourth law, but this isn't a law of motion, but rather a law of gravitation. Now what does this law state? Imagine there are two planets. One is the Earth, another is Mars. These two planets have masses, so they will attract each other. Now what does this force of gravity depend on? Newton said that this depended on their masses and their distance. How and why? So we know that weight equals to mg, and weight is a type of force, so we can also write that force equals to mg, and thus force is directly proportional to mass. If a body is too much far away, the force that body will receive or experience far less than a body which is closer, and that is just common sense.